Let's now look at logical volume management. This is a means of being able to aggregate storage into storage sets for simple management, which allows you to extend, resize, reduce, as well as allocate storage on the fly. So logical volume management, or via its acronym LVM, and there are numerous features, of course, including the ability to create volume sets, resize storage on the fly, which means hot without having to reboot the system, and provision storage as necessary. So provision storage as necessary. The volume set feature is the most important because it allows us to aggregate. So aggregate storage from disparate sources. That means you could have SATA, IDE, SCSI, iSCSI, you name it. So long as the kernel is able to see the storage, you can allocate it into a volume set. Of course, there are inherent weaknesses in the argument of spreading storage across the network as well as locally and so on with respect to things going awry, but nonetheless, LVM will allow you to aggregate storage wherever it's available on the system without regard for storage type. It does this by creating a hierarchy which represents the LVM storage tree. So what we'll do is start talking about these things, including the LVM storage hierarchy. So before creating anything LVM related, it's important to understand how the hierarchy works. The most basic object in the hierarchy is a physical disk or a physical volume. Physical volumes are aggregated into volume groups, and from which we create logical volumes that we store data on. So there are a number of ways in which you may look at it. A logical volume is where you configure the file system. So configure file system at this level. But in order to make a logical volume, you need to have first created a volume group. And a volume group represents one or more physical disks or volumes. We say volumes because you can aggregate partitions from one or more disks. So a physical volume may not necessarily be the same as a physical disk, although it should be for performance reasons. And then beneath the volume group, you've got physical volumes. And these are, for example, like dev SD B4, which we've yet to create, dev SD C3, etc. So they may be partitions. You partition them using fdisk or parted. And in particular, you set them to LVM type 8E as opposed to Linux type 83, on which we overlay ext file systems, or 82 for swap. So first we need partitions that are set to type 8E. We then arrange those partitions into volume groups. That's where the aggregation takes place. Once you have a volume group, you then abstract logical volumes from those volume groups. You could, for example, create one logical volume which represents the entire storage presented by the volume group, or n number of logical volumes that represent n number of partitions or sections of a volume group. So it's a three-tier hierarchy: physical volumes, partitions, volume groups, and then logical volumes on which we overlay file systems. So how do we create this hierarchy? Create LVM storage hierarchy. And we've outlined 6 steps. These are 6 common steps, plus or minus 1 or more depending on the methods used. And they include, of course, first creating the partitions of type 8E or type LVM to associate with our logical volumes. So step 1 for us is to create LVM partitions on available disks using either parted or fdisk. So let's see what's available in our system. Left disk L, dev SDB, and dev SDB is currently configured with 3 partitions, 10, 10, and 1 in terms of storage, so 21 gigs are used, leaving 15 gigs available. So we could use, for example, 10 gigs to create our first LVM, or 5 or what have you, it doesn't matter. So using either parted or fdisk, let's go with parted, dev SDB, that focuses on that particular drive. We use makepart to set the partition, its size, etc. And then we can define the type that the partition will be. So let's go ahead and makepart. And we can always, before doing so, just print to see what's there. So it's going to be partition number 4. And its size is going to be, let's say, 5 gigabytes. So makepart primary, and we will start at, let's say, 20 GB to 25 GB. And it says the closest they can give us is 21.1. This is fine. And then let's print to see, and we'll tell it the resulting partition is not properly aligned for best performance. We'll just ignore it. And let's print. Of course, the kernel complains about the addition of the new partition. So from 21, the size is unimportant because we're creating volume sets as opposed to RAID sets that require the same size. So this is one partition that we may have to reboot the system to realize, which is about 4 gigs. And its type is currently not set. If you run help, you'll see that the set option is there to allow you to set a particular partition to a particular type. And if you do a help set, so you don't have to memorize it, you'll see that you can set the partition number that's of interest to any of the types indicated. So, for example, set number 4, and this is going to be to a particular flag, one of which will specify LVM, and the state should be on. Let's print the partition table. So now we see number 4 is set to LVM. So that's our first LVM partition. Now let's select a different disk, dev SDC, print the table, and currently 11 gigs are in use. So let's define a new partition. Let's makepart primary. Could be extended, but for this case we'll go with primary. And we'll start at, let's say, 11.2 GB to, let's say, 16 GB, and it'll adjust as appropriate. In fact, it didn't have a complaint. Let's print, other than the fact that we may have to reboot. And then we should set the type again, help set, and set number 3 to LVM on, then print the table. So now this is another LVM partition. Let's quit. We can use fdisk or parted. Let's list dev SDC. There are the partitions in dev SDB. Now whether or not we'll be able to write to the partition immediately remains to be seen. But to avoid confusion, let's just reboot the box. And it should be back up momentarily, so let's just note, create LVM partitions on available disk. A1 we use parted on dev SDB initially, and within parted we made a partition using makepart. We called it a primary partition, and we put the start and the end, which can be specified in terms of blocks or size or otherwise. And then we set the type using the set option, And each of the options have corresponding help, so you can run those when necessary. So set, for example, and this was partition number to LVM and then on, and then we rebooted because the system did not take, the kernel did not take the changes directly. Again, this will not occur on all systems. It may just happen on this system. It's a slightly older system, so a reboot fixes that. Let's see whether or not the system's back up. We'll send a few packets to it, and it's possibly up. It's up, so let's reconnect and confirm that the partitions have been preserved using parted_l, for example. This will enumerate all of the partitions. Here's the third partition on SDC, and here's the fourth partition on SDB. And just note that this fourth primary partition makes it impossible for us to create extended and logical partitions on this disk SDB. So at some point, if we intend to make use of the remaining storage, we'll have to remove one of these primary partitions, perhaps the swap partition, and create the extended partition there to encompass the remaining blocks on the disk. So now LVM seems to be ready to move forward. So we've created the partitions. These are the base partitions that are needed. Now we start to interact with each stage of the hierarchy. We start with the physical volumes. There are a series of tools for each layer of abstraction: physical volume, volume group, and logical volumes. And they're logically labeled, and they're similarly labeled so that you can remember them. PV create allows us to create physical volumes, insofar as LVM is concerned, out of partitions that have been labeled type LVM or type 8E. Simply execute PV create followed by the dev tree location, dev SD, and let's go with SDB, for example. We know we have SDC3 and SDB4. So SDB4 and dev SDC3. You can specify more than one partitions on the same command line as options to PV create, and we'll simply loop through each of them. So this will create physical volumes out of these particular partitions. So creates physical LVM volumes from partitions that have been labeled, of course. And when it's complete, we'll execute PV display to display the various physical volumes that are associated with the LVM configuration, which should include any other physical volumes that have been defined during installation and otherwise. So let's associate these, and notice both were successfully created. PV display will reveal all of the physical volumes. Here's dev SDC3 and dev SDB4. So 4.5 and roughly 3 6/10 gigabytes. So we have roughly 8 gigabytes. And here's dev SDA2, which was constructed during installation. So it is available for usage otherwise. And it appears to be the partition that is associated with the root file system because it's 33 gigabytes. So that was the original physical volume that was associated with the volume group named VG_LinuxCBT_serve1. We can associate our newly created physical volumes with the same volume group or create a new volume group altogether. So we've created these physical volumes. We have 2 that we can aggregate into storage. And supposing we're going to mount maybe /var1 off of these things. So we can create a volume group perhaps dedicated to var if we'd like. So that leads us to the next step, and that is to create a volume group. So this volume group creation command is VG create, just like the physical volume creation command is PV create. So VG create followed by the name of the volume. So we'll call this vol group var, for example, followed by the disks that are to be associated with the volume group, which include dev SDB4 and dev SDC3. So this associates or allocates both physical volumes to the volume group. So allocates both volumes to the volume group, which leads us one step closer to creating logical volumes on which we overlay file systems. So let's take a look to see how this will work. Currently, if we execute VG display, you'll see the lone volume group that's defined, which governs the volumes that were instantiated during installation. So we're going to create a new volume group, naming it vol group var. And this was successfully created, so let's re-VG display to see what's there. And now we have two volume groups. Vol group var, which is the aggregate of the two pieces of storage for a total of 8.23 gigs, and the original created during installation. Now we move on to the next layer of the hierarchy, and that's logical volume creation using the LV create command. So, LV create, and this is where we specify specifics such as sizes, so that when we overlay the file system, it matches the size registered in logical volume. Now, you don't need to specify the entire 8.23 gigs. You can specify a subset of it, for example, 5 gigs. So LV create 5 gigabytes off of vol group var. This creates a 5 gigabyte volume, leaving the remaining 3.23 gigs available for allocation at some point. It's always a good idea to not exhaust your storage when creating storage items. If you'd like to name your logical volume, then include the N option with a name, such as log vol var, for example. And that way, when you reference it in the dev tree, it's the name that you've elected and not one that's auto-allocated by LVM. So let's take a look to see what happens when we try to create this logical volume. Of course, LV display will be the command that we'll use to display the logical volumes that are defined. LV swap was defined during installation to be a gigabyte out of the volume group VG_Linux CBT serve 1. Similarly, LV_root is associated with the volume group Linux CBT serve 1, and it's the lion's share of the storage. And now, logical volume log vol var is associated with vol group var. Now this path becomes important because this is what we'll reference to mount the logical volume once we've created a file system on it. Let's copy this path because the next step for us is to create an ext4 file system. So that leads us to step E, which is 5 of 6. And let's just note that we will make the file system using make2fs, type ext4 with journaling turned on this particular path, which is 5 gigs. So let's just note this overlays ext4fs on LVM volume, which can be manipulated further as the need arises. So let's paste this into our shell to overlay the file system. And this will go ahead and overlay it rather quickly because it's only 5 gigabytes. And now we have this new dev tree mountable volume group logical volume available to us, which is alias to DM2. So we're now ready at this stage to make a directory and mount log vol var, which leads us to the 6th and final step. Of course, there are ancillary steps such as testing, for example. So let's lump into the final step, make directory var, let's call it LVM var. LVM var 1, for example. So we'll make directory that and then mount the full path dev vol group var log vol var into LVM var 1. That'll do the trick. And then the implicit 7th step is to simply update etcfs tab to reflect the fact that there's a new LVM mount point available that is to be initiated whenever the system is invoked or run levels switch between appropriate multi-user phases 2 through 5. So let's go ahead and make this structure and mount, and then we'll follow up with a mount command to be sure that it's worked. Let's echo the exit status, and now we see that it's been mounted read-write ext4 LVM var1, which means, of course, there's a lost and found in the directory, and a df-h will reveal that it's 5 gigabytes with overhead for ext4 management, leaving us roughly 4.6 gigabytes, so roughly 3% is used. But we now have a new logical volume instance that's available, but of course, it will not be reinitiated when the system reboots, unless we update etcfs tab. And also, you may note that the df output shows dev mapper as opposed to the path that we've referenced. If we look at dev mapper vol group var log vol var, you'll see that it points to dm2, the same device that our other item that we've created, which is / dev vol group var log vol var, points to. They're both aliases to the same device, the same logical volume device. When you see those DM devices, they're LVM devices. fdisk displays them, for example, when you dump the full contents of the disk. So there's DM2, for example, 5 gigabytes, or DM0, 1 gigabyte for the swap partition, or any of the other items. So our LVM's up. Let's update our etcfs tab using nano etcfs tab. And somewhere in the list of mountable items, perhaps after swap, we can mount it wherever we feel we want to, and we'll just list it in this section here. So this is going to be the full path dev vol group var log vol var to be mounted at LVM var1 as type ext4 with defaults, and the check order to be 1, 2. So this will mount for us. And of course, confirmation comes when you unmount, either using the full dev location or the mount point, and then remount. Let's just mount to make sure that it's not there, and then let's mount A to make sure that it mounts, followed by a regular mount, should show that it's remounted. So LVM var1 now exists and will persist as the system is rebooted. FreeM still shows all of the swap space that we've allocated, so including the swap file and the 2 partitions plus the original LVM swap partition. So those are still intact. We have enough swap storage. We now have additional logical volume managed storage. Let's again just recap the hierarchy that's carried out. LVM is arranged into three levels of a hierarchy, including the physical volume, the volume group, and the logical volume. Physical volumes are the lowest level of abstraction that are close to, or are the closest to, the partitions that are defined on the disk. They're a way of flagging certain partitions as being able to be participants in logical volume management. Those physical volumes are arranged into containers or silos known as volume groups. So they're aggregated. They're created as volume sets. So all of the storage, whether 2 or 2,000 partitions, are brought together into one large volume group. So it could be as small as 8 gigabytes or as large as multiple, perhaps petabytes, up to the limits allowed per ext4 file system. 1 exabyte currently. From the volume groups, we extract logical volumes. We've extracted 5 gigabytes out of the 8.23 gigabytes for var, leaving us 3.23 gigabytes to associate with something else. Each layer of the hierarchy has tools: display tools, creation tools, extension tools, etc. If you tab out PV, you'll see the various tools for the physical volume management. PV create, change, display, remove, resize, scan, etc. PV display displays the various physical volumes, partitions that may participate in logical volume management, including the most recently added items. It lists the volume group membership, so you always know to which volume group a particular partition belongs. So dev-sdc3 belongs to vol group var. dev-sda2 belongs to the originally set up during installation vg_linux cbt serve1. sdb4 is also a member of vol group var. Their sizes are included, the physical extents, total physical extents, UUIDs, etc. VG display shows the various volume groups that are defined. VG_linux cbt serve1 and its aggregate size, whether or not it's read-writable and resizable, because you can define volume groups to be read-only and not resizable, for example. Vol group var, its format, LVM2, the current version, the fact that it's read-write, and that it's resizable, and its aggregate size. As we provision storage as we go along, we can continue to add to vol group var, thus extending its size from 8.23 gigs to additional sizes, as we'll see in subsequent sections. That's at the volume group level. At the logical volume level, LV display enumerates the logical volumes on which file systems are overlaid. So here's a swap that was created during installation, the root during installation, and our log vol var. The hierarchy is presented beneath the dev tree with the volume group as the holder or container and one or more logical volumes beneath the volume group. So the volume group is truly the container under which logical volumes exist, because they're abstractions or subsets of the volume group. We see that this volume, logical volume, is 5 gigabytes. So that means there's a little space available for allocation of more storage as we see fit. And we overlay ext4, ext3, or other file systems that are supported by the kernel using standard tools once we have created a logical volume. So we've created with LV create and the appropriate size, and then we use make2fs with the ext4 option to overlay an ext4 file system. We then made a mount point and mounted the dev location to that mount point, and then of course updated etcfs tab. So update etcfs tab for persistence. And that's how you set up LVM. Of course, there's a lot more that you can do with LVM, including resizing and other things. But this is how you get it up and running from the shell without relying upon GUI-driven tools. So this is a little bit about LVM setup. Now we'll move on to some other things you can do with LVM.